Okay, so we are talking about order statistics problem. The problem is to find given n numbers and we need to find out ith smallest element. So this is the problem for order statistics. So I is any index from 1 to n. So if I is equal to 1, this is minimum, if I is equal to n, this is maximum, and if I is equal to n by 2 ordered, then it is called median. So we have seen the select algorithm. Basically we are using the partition algorithm, and we partition we have given this array of numbers. So say this is a array. So we choose this as our pivot element x. So this is p to q, and then we call the partition. Then x will be sitting somewhere here, and this is the index of x where it is sitting, and this is p, this is q, and then so all the elements over here are less than x, all the elements over here are greater than x. Okay, so now this is k. If we choose k is equal to r minus p plus 1, then k is basically rank of x. Now if I is equal to k, then we got our ith smallest element. Otherwise, if I is less than k, this is the divide and conquer technique. If I is less than k, then we know our ith smallest element is here. Then again we call the same function, this is the conquered step, on this subarray. Otherwise, if I is greater than k, then we know the ith smallest element will be here, but we already reached the kth smallest element. So we need to look at this subarray with I minus kth smallest element. Okay, so this is the new I for if you have to look at this. So this was our select algorithm. Now this, the time complexity of this will depend on the partition. So how the partition will be over this array. I mean, if the partition is good partition, I mean rather if the pivot element is minimum or maximum, then it is a bad partition. Then it is, so worst case we have seen, if the pivot we choose always minimum or maximum, then the worst case will be 0 is to n minus 1, and in that case the recurrence is theta n. So this is our recurrence, and this is the arithmetic series. So this will give us order of n square. And what is the best case? Best case is basically if the partition is n by 2 is to n by 2, then we have seen the recurrence is T n is basically, so T n by 2 plus theta of n is the cost for the partition algorithm, and this by master method of case 3, this is order of n. And even if we have almost best case, right, if we have partition like 1 by 10 is to 9 by 10, then also we have seen the recurrence is T n is equal to T 9 n by 10 plus theta of n. So this is again will give us theta of n. Okay, so this is the almost best case. So the lucky case. So but the worst case is this. Okay, so now we will talk about a randomized version of this algorithm. This is our select algorithm. This is a divide and conquer approach. We divide the array into two sub array, and we put the pivot in some by its position, and then we call we conquer by calling again the same function select either on the left side or right side depending on the value of I. Okay, but this is the analysis of that code. Depending on the partition, it will give us the worst case or best case, lucky case, unlucky case. So let us talk about randomized version of this. So if we know that so in the randomized version of this, So, this is called randomized rand select. So, we have given an array and we have to find out the ith smallest element. Okay, so here the idea is to choose the pivot element randomly, so that there is a chance that the partition will be the good partition in some of the subsequent cases. So, in that case we can say, we will in fact we will prove that the expected runtime will be order of n. Okay. So, what is that code? Code is, if p is equal to q, then we just return AP, else what we do, we just call a partition. Now here we call the randomized partition. A P to Q. So, what is this randomized partition? So, in our original partition algorithm, if you recall the quick sort, our quick sort algorithm, in the partition algorithm, so this is the array A P to Q. So, we choose A P as a pivot element. This was our original partition algorithm, but in the randomized version of the partition algorithm, any one of these index will be the pivot element. So, like so any one of this index we can choose as a pivot element. If there are n elements, so they are equally likely to come. So, we choose a index randomly from this P to Q, and then we choose that element as a pivot element. So, that is the randomized version of the quick sort, and it will return the R. R is basically the index where x is putting after calling the pivot, and then we choose k to be r minus p plus 1. K is basically rank of x. X is the pivot element which is chosen randomly. Now, the code is similar, if similar than the select code we discussed in the last lecture. So, if I is equal to k, then we return x, that is our ith smallest element. Else, if I is less than k, then again we have to call this randomized select. So, I is less than k means we have to look the ith smallest element in this sub array. So, we call again randomized select on this sub array, left sub array A P to r minus 1 with the index I. Okay. Else, if I is greater than k, then we have to call the rand select on the right sub array, but we already explored the kth smallest element. So, now we have to get the I minus kth smallest element, A r plus 1 to q with I minus k. Okay. So, this is the divide and conquer approach. Divide and conquer. So, basically we divide the problem into two here it is one sub problem. We either look at the left subtree or a left array or right array. Okay, now what is the time complexity? So, time complexity will depend on the partition. So, worst case we have seen. So, this will take the order of 1 time, this partition will take linear time, and so these two will take. Now, this and this, so these two, so either one call. So, it will depend on the nature of the partition. If we are lucky, if the partition is good partition, if the pivot is good pivot, then we know this is either n by 2 or it is some portion of the some fraction of the n. But if the worst case it is n minus 1. So, depending on the partition, it is basically give us the time complexity, but worst case time complexity is always n square. But this is a randomized version. So, we want to look at the average case analysis. So, expected runtime. So, that we are going to do now. So, for that let us denote the time complexity as Tn. Tn is the runtime of rand select with n element. Okay, now this is randomly chosen pivot. So, the partition, we do not know which partition will come. So, that is why this is basically a random variable. This is basically a random variable. Okay. So, if the partition is say 0 is to n minus 1, then we know Tn is basically T0 plus, I mean Tn minus 1 plus theta of n. So, if the partition is 1 is to n minus 2, then we know Tn is basically T of n minus 2 plus theta of n. And if the partition is k is to n minus k plus 1, n minus k minus 1, then the dot dot dot, then the Tn will be basically T of maximum of these two. So, it is basically partition is this, means we have x is sitting here and there are k element over here and k minus n minus k minus 1 element over here. So, depending on the value of k, we are talking about worst case runtime. So, we go for the maximum size. So, maximum is depending on the value of k, it will be a max of k comma n minus k minus 1 plus theta of n is the time for partition subroutine. Okay, so this way we continue. So, we can write Tn in the functional form like this. So, depending on the partition, it will be of the particular form. So, Tn is basically in the functional form, it is basically T of max of 0 comma n minus 1. This is for symmetry we are writing. We know max is n minus 1, but still for the symmetry we are writing this. If the split or partition is 0 is to n minus 1 split, or it is T of max of 1 is to n minus 2, if the split is 1 is to n minus 2 like this, dot 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 T of max of k comma n minus k minus 1 plus theta of n for the partition. So, if the split is k is to n minus k minus 1, okay, dot 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 T of max of n minus 1 comma 0 plus theta of n if the split is n minus 1 comma 0 split. Okay, so this is the Tn, form of the Tn in the functional in this form. Now, that is why Tn is a random variable, because we do not know which partition will occur, because our pivot is randomly chosen. Okay, so before running this, we do not know which one is going to be our pivot. So, that means we do not know which partition will occur, but at least one of this partition has to be occur, but we do not know which one. So, that is why Tn is in this functional form. Now, we want to take the expectation of this Tn, we want to calculate the expected value of this Tn, and that we are going to show it is linear. So, for that we want to take this functional form to algebraic form. So, for that what we need to take help of the indicator random variable. So, now we define indicator random variable. So, xk, so let us just define the indicator random variable xk. Xk is 1 if the split is k is to n minus k minus 1 split, 0 otherwise. Okay. So, this is the, so one of the xk value is 0. So, if the partition is this, then this is x0, x0 is 1, then remaining all other x value is 0. So, now one of the partition will occur and they are equally likely to occur. So, that means probability of xk equal to 1 is 1 by n, because there are n partitions. So, that is why it is 1 by n. Okay. So, now we want to write this in terms of algebraic form, because now we have a indicated random variable. So, one of this xk, one of this partition will occur, that means one of that xk is 1, remaining as 0. So, basically we can write Tn as in the sum form summation of xk, that particular one of the split is 1 into that corresponding t. So, this is basically t of max of k comma n minus k minus 1 plus theta of n. So, this is basically our algebraic expression, and this t k is running from 0 to n minus 1. So, one of the partition will occur and that corresponding xk is 1, remaining xk's are 0. So, that is why we can write this in terms of this. Okay. So, now we want to take the expectation on both sides. So, if you take the expectation of Tn, so this is basically expectation of this. Now, summation of xk into t of max of k comma n minus k minus 1 plus theta of n. So, this k is from 0 to n minus 1. Now, expectation is a linear function, we can take the expectation inside. So, summation of expectation of xk into t of max of k comma n minus k minus 1. So, this is the closing bracket of this plus theta of n. So, this will come with xk into this, okay, and this k is from 0 to n minus 1. Okay. So, now we want to take the, this is xk into some random variable. So, that means we have something like that w y. We have two random variable w and y, expectation of w into y. So, if they are independent, then we can written as expectation of w into expectation of y. So, if y and w are independent random variable, independent, why independentness is coming here? Because here we are choosing the pivot element randomly. So, for that we need to generate the random number in the subsequent steps also. So, this all choice of random numbers generation are independent. So, that sense it is coming, the independentness is coming. So, if we assume that independentness, then this can be written as summation of expectation of xk into expectation of t of this thing, maximum of k comma n minus k minus 1 t of this plus theta of n. Okay. And this k is varying from 0 to n minus 1. Now, what is the expectation of xk? Now, probability of xk is equal to 1 this, and probability of xk is equal to 0 is basically 1 minus this. So, this is a 2 point, this is a Bernoulli random variable. So, expectation is basically 1, so 2 value 1 and 0, 1 into its probability plus 0 into its probability. Okay. So, this is basically 1 by n. So, expectation of xk is basically 1 by n. So, we put this value over here 1 by n. So, this will basically give us, can we erase this? So, this will give us expectation of t of n. So, this is 1 by n, we take outside summation of this thing. So, expectation of this plus this, and this is nothing to do with the expectation. So, this will basically give us again theta of n. So, this is basically summation of expected value of t of max of k comma n minus k minus 1 plus theta of n. This is from k from 0 to n minus 1. Okay. So, now how we can simplify this further? So, this is basically okay. So, okay, let us just try to simplify this further. Now, this is basically we are taking the expectation of t of maximum of this. Now, k is varying from 0 to n minus 1. Now, if k is up to n by 2, then this maximum will be n by 2. I mean, so this can be written as this is 2 by n summation of expectation of t of k, where k is varying from n by 2 to n minus 1 plus theta of n. Because see, when k is equal to 0, then the maximum is n minus 1. When k is equal to 1, then maximum between 1 and n minus 2 is n minus 2. So, basically, so if k is varying from 1 to like this, n by 2, then n by 2 plus 1 to n. Now, if k is 0, then maximum is n minus 1, k is 1, maximum is this like this. So, k is if k is n by 2, then the maximum will be n by 2. Again, from here also we have maximum n by 2 to n. So, basically we have twice term, this sum is basically we have 2 of this. Is this clear? Okay. So, now we have to simplify this more. So, this is basically the expression we got for the expected runtime. Now, how this is linear, we have to show that. Okay, to show that, so we have to prove that this is, we want to prove expected value of Tn is basically big O of n. So, for that we want to take this as C of n, some constant, for some constant C greater than 0. Okay. So, this how we can prove this? So, now we will prove this by method of induction, the substitution method. Now, we assuming that this is true, this result is true, this is the induction hypothesis. So, we assume this result is true for up to n. So, that means expected value of T of k is basically less than equal to C k for all k less than n. This is our assumption, and then we prove that this is true for n also. So, this is the way, this is the substitution method. Okay. So, we have this expression. So, this is basically the expression we have 2 by n summation of k is equal to n by 2 to n minus 1 expected value of T of k plus theta of n outside. Okay. So, now we will use this induction hypothesis. So, we will use this induction hypothesis because this is the all the k value n by 2 to n minus 1, these are all less than n. So, this will give us 2c by n summation of k is equal to n by 2 to n minus 1 plus theta of n. This is by using induction hypothesis. Okay, so this is by using the induction hypothesis. Now we have to prove that this is less than C of n. So to show that, we need to take a inequality which is basically telling us this is a fact. So summation of k is equal to n by 2 to n minus 1 is basically can be shown as 3 by 8 n squared. Okay, so this needs a proof, but you can prove it by again by induction. So this expression, this inequality we are going to use. If we, so this sum is similar to this sum. So this is again 2c by n into 3 by 8 n square plus theta of n. So this is basically giving us what? So this is 4, this n cancel 1 n. So 3 by 4 c n plus theta of n. So now we have a control on c. C is the constant we can play with. So we choose c in such a way that this should be less than. So we choose c such a way that this should be less than. So this we want to write as this Cn minus Cn by 4 minus theta of n. Okay. So this expression, if this is positive, then we can write this is less than equal to Cn. But to have this positive, we can choose C is large such that it will be positive, because this is theta of n means it is some expression in n, some function in n. So we can choose C in such a way this will be the positive. So this is basically less than n. So this is the proof. So expected value of T of n is basically less than C of n. So this is basically telling us by the method of induction the expected value of basically big O of n. So this is the average case analysis of randomized version of the randomized select. But this is the average case, but the worst case is always n square, because even we are choosing the pivot randomly, it may happen that always that pivot is coming as minimum or maximum. Although this is random choice, but that chance is there. So the worst case is always order big worst case is always 0 to n minus 1 partition. Okay, but this is the average case analysis for this randomized version of the select. Thank you.